Hello and welcome to this first live stream on the topic of CSES problem set. In this live stream, we will be going through the CSES problem set, which contains a huge list of interesting algorithm problems. I'll be picking these problems from this website called CSES.fi that you can see at the top of the browser, in the address bar of the browser. So this website is a highly recommended resource, especially for beginners who want to practice solving algorithms and data structure problems. And that's why I picked up this website to do this series of live streams. I plan to make a series of these live streams where I go and solve a problem from this CSES problem set. So let me get started. You can see the website already. It is CSES.fi. I will go ahead and click on this panel that says CSES problem set. And here's a huge list of problems. You can see in the beginning we have some introductory problems, and then sorting and searching, dynamic programming, and so on and so on. So these problems are arranged by themes. They are very well curated problems. And the fact that it is arranged by themes helps beginners to pick some interesting areas where they want to focus on and practice those areas well. And this is the reason why this is a very highly recommended resource for someone who is beginning to practice solving algorithm problems. I'll pick the first problem for this live stream. Let us pick this one, weird algorithm. I have solved this before, but I'll just solve it once more for the sake of completeness in this live stream. Let me create a file first to solve this problem, and then we'll go through the problem statement and then write some code. I'll call it weirdalgorithm.cc. I like to name my C++ files with the extension .cc. I know .cpp is more popular, but I'm used to .cc. When I began working on C++ professionally, the place where I used to work had .cc as the file naming convention. So I just got used to it. I'll be using .cc, even though .cpp is far more popular for naming C++ files. Let's see the problem statement. Consider an algorithm that takes as input a positive integer n. If n is even, the algorithm divides it by 2, and if n is odd, the algorithm multiplies it by 3 and adds 1. The algorithm repeats this until n is 1. For example, the sequence for n equals 3 is as follows, and you can see this example here. So the first number given to us is 3, and since this is odd, we're going to multiply it by 3 and add 1. So 3 times 3 is 9, plus 1 is 10, so the next number is 10. And when we get an even number, we just divide it by 2. So when we have 10, we divide it by 2 to get 5. Now we've got an odd number again, so we multiply it by 3 and add 1. So 5 times 3 is 15, plus 1 is 16. And then we've got an even number again, so we divide by 2 to get 8. We have an even number again, so we divide by 2 to get 4. We divide by 2 again to get 2, and then we get 1. That's pretty much it. We'll just be given this input, the starting number n, and we need to produce the sequence which terminates with 1. It's a very simple problem, quite easy to code. We'll do that in a moment, but before that, let's take a few moments to look at the sequence. So there's an interesting question. Will it always end with 1? Is it guaranteed that no matter number we start with, we will end up with 1? Is that guaranteed? And that's a very profound question which has not been answered yet. It's an open mathematics problem and it has not been answered. And this thing is called the Collats Conjectures. Let me just show you the Wikipedia page for this. Collats Conjecture. And this is also called the 3n plus 1 problem. It's the same thing that we just saw. The question is, will this always end with 1? So it has many other names. Like I said, it is also called the 3n plus 1 problem. It's also called the hailstone sequence, which you can see here. I'm highlighting it. The numbers are also called hailstone numbers, and so on. So it is a very popular problem, also an open problem. It's an unsolved problem in mathematics. But of course, we have tried testing this sequence with various numbers, various large numbers that we can test using computers, and no matter what number we try it with, we always see that it does end with 1. But that is not sufficient to claim with confidence that it will always be true for all integers out there, because there are infinite number of integers and we can't really test this sequence with infinite number of integers. Coming back to the CSES problem set, so we know what the problem is, and we just need to print a line that contains all values of n during the algorithm. A fairly simple problem. Let me go ahead and code it. I'm choosing C++ as the language of implementing for implementing the solution. So we're given an integer, and what is the range of that integer? It can be as big as 1 million. I'll choose the data type int for it. I'll note down the range. Now I'll go ahead and read this line of input. Okay, good so far. So I've read, there's only one line of input which I've read now. And now I just need to go and generate the output. And I'll have to keep iterating through the sequence until I reach 1. So let me write the loop for that. We do want to output the first number we receive. For example, if we receive 3 as the input, we do want to output that number itself. So I'll just go ahead and print that right away. Now the next thing is that I have to do is to decide the next number in the sequence, and that depends on whether n is even or odd. The next number is going to be decided based on n is even or odd. If n is even, we just divide n by 2 to get the next number. If n is odd, we compute 3 times n plus 1 to get the next number. Really simple. And in the end, we will get 1 that is computed, but it's not, so that the last number 1 is being computed here, but it is not being printed. I'll go ahead and print that last number, which is going to be 1. Let me save this. Let me test it out. Compiles fine. That is good. I'll just compile it with a few more options. I'll be using the C++ 11 standard mostly in these live streams. I'm just telling my C++ compiler to make sure that I'm conforming to this standard, and I'm enabling as many warnings as possible. Okay, it's still compiled cleanly. Let me go ahead and execute this. Let me input this number 3. And there's the output 3, 10, 5, 6, 8, 16, 8, 4, 2, 1. Looks good. Let me make sure the data types that I've chosen is correct. Okay. I've chosen the data type integer, but we can't know in advance how big these numbers can grow. These numbers can grow really, really large. In fact, for some inputs, these numbers can grow so big that they may not even fit within the size of long. That's a possibility. But I'm guessing there will not be the test cases will not be having such inputs. That's what I'm guessing. There's no indication of whether the numbers will grow so big or not. Let me go ahead and run this first, and if I come across a test case that shows that the numbers can grow beyond the range of int, then I'll change this to long. Okay, I've selected the solution here, and let me go ahead and submit it. Yes, so there are some errors there, and I'm pretty sure those errors are because of the integer size. It would have been nice if the problem had some indication on how big the numbers within the sequence could be. Yet another way could be to have some prior knowledge, like within this range 1 to 1 million, how big the numbers could become. But since I don't have the prior knowledge, I'll just rely on the results that I got. Let me check this test failure. And yes, the numbers are becoming quite big. Are they becoming bigger than the range of integer? I think so. Okay, let me just do a quick test here. And int can be this large, assuming it's a 32-bit integer implementation. That's what I have on my system, and that's what we have on the CSES online evaluation system too. And this number that is given here is quite big. Okay, so I'll just change this to long so that we have sufficient size for containing this big numbers that comes in the middle of a Collats sequence. Let me test the program again. Of course, there should not be any error. Let me test this specific input. Okay, 138367. Let me just compare it visually once. Yeah, it looks the same. So I'll go ahead and submit this now. All the test cases passed this time. So the integer size was indeed the issue for the previous failure. Alright, so that's it for this live stream in which we solved the weird algorithm problem. This was the first problem in the CSES problem set. Thank you for watching. Bye and have a nice day.